Well, greetings and welcome to 1.3, the third and last part of Chapter 1 for Workplace and Apprenticeship 20. Today we're going to look at the same topic just from a slightly different slant. We're going to look at slope, and slope is a rate of change. And we're going to look more specifically at different situations where that applies. And you can see on the page right now there's a graph of skateboard deck output. So they're producing skateboards, and you can see there's a red line and there's a green line, and you can see that the green line is producing more skateboards per hour than the red one is. And how do you figure out what that value is? So if we look at the green line, if there's 160 skateboards produced in 8 hours, we do some simple division. That means there's 20 skateboards per hour being produced by the person who's making the green ones. And for the reds, it's 80 divided by 8, which is 10 skateboards per hour. And really all that we've done is we've done the rise, which is your 80 and your 160. So that's how much up it goes from the start to the finish. Is 160 up and 80 over. And then with the red line, we go up 80 and over 8. It's rise over run. So rate of change is rise over run. You're also going to need to be familiar with the definitions of dependent and independent variable. So make sure that you've got those handy for when you need them. Another example that's similar is involving money and pay. And you can see there are two people here, and I won't butcher their names because I'm pretty sure I don't know how to say them, but nevertheless, the person with the letter K makes 20 bucks an hour, and the U makes 16 bucks an hour plus a $20 gas allowance at the beginning of each workday. So when you look at the graphs that compare the two, Uriak starts at $20 and ends up having their pay grows less quickly as the red, but the red starts at 0 and goes up faster. So the number of hours would determine the amount of money earned, and you can see that if this person works, or if they work less than 6 hours, then it looks like green's going to earn more. If it's more than 6 hours, it looks like the red is going to earn more. And to figure out that earning or that rate of change, it is simply your rate of pay. So in this case, the rate of change for the red line was $20 an hour, whereas the rate of change for the other was $16 an hour, just depending on where it starts. Now, one of the things you're going to be asked to do is to create equations to represent the situation. So if I want to find the amount of pay that Kalirak is getting, the K person, then the amount of pay, I'm just going to use the letter P, is $20 an hour. So 20 hours, or $20 times the time, plus 0 off the start. They do not make anything right off the bat. It all depends on time. Whereas for the second person, Urayak, the pay is less, $16 per hour, but they start off with the $20. So the equations are similar, yet different according to the rate of change. And you're going to have to do that and answer questions about questions like that. Another example here is looking at Doug. I can pronounce that one. What a great name. That's awesome. Anyways, Doug has used a router to create a groove in this board. You can see from point A to B is that groove. We're supposed to figure out the slope of that groove and then figure out how long the groove is. It's a groovy question, isn't it? So you can see I drew on there with the red. Maybe you can't see it as well as I would like to. I'll use yellow here instead. Okay, we have a rise and a run going from point A to point B. And if we go from point A to point B, can't really see the coordinates now because I've covered them up, but point A goes from 4 to 14 on the x-axis anyway, so it starts at 4, ends up at 14. So the run is 10 because from 4 to 14 is 10. The rise, point A is at 12, point B is at 28, so that's a rise of 16. So when I want to find the slope of the triangle, or the slope of the line, is rise 16 over the run 10 which as a decimal would be 1.6. As a fraction in lowest terms would be 8/5, or you could say 8 to 5. All those three are the same. We're also supposed to figure out the length of the groove, so I'm just going to use the letter G to represent that. We essentially have a right triangle, that's what we have, where that's the length of the groove. The run is 10, the rise is 16, so we would use Pythagoras' theorem to determine the value of G. So 100 is 10 squared, 16 squared is 256, so you end up with 356 is equal to G squared, and then you would use your calculator, I assume, to square root that number and to get the answer. And it's about, let's say, how much we should go to or how accurately we should state our answer. It does not. So I'm going to round to 18.9, and that is measured in, doesn't look like we're told if it's in any length. So I would just have to put units. We don't know if it's centimeters or inches or what it is measured in. So that's the basic idea behind the last part of chapter 1. And so your job now is to practice, make sure your definitions page is up to date. Then there's a review assignment called Practice Your New Skills on page 52 and 53. And you should be ready for your test. So when you're done those, you let me know and we can get that test completed and you can be done with chapter 1.